adding in an enemy, getting the chasing action going on, that's when it finally starts to get fun. Now that we have our animated sprite moving around on screen, so it moves based on keyboard input. What we're going to do is we're going to make a second class. Right now we have our sprite class, which is really our player class, and then we're going to make a second class. This class will be called enemy. Now this enemy class is going to be very, very similar on many levels to the sprite class. So much so that as if we were doing more advanced programming, we would just have a generic sprite object class, and then we would have classes that are based on that, or children classes of that, and then those classes would have all the core functionality of the sprite object class, but then they would have their own unique enemy methods and enemy data that they need, player methods, player data, and we could build all these different ones. But right now we're going to, even though it's repetitive on some of the code, it keeps it easier if we just have a second class, even if it is nearly the same. So the easy way to go about that is I will take my sprite class and I'm just going to copy and paste, and then now I'm going to leave sprite down at the bottom so I don't have to scroll up and down quite as far. And I'm going to now refer to this second one as enemy. And you have to change the name in it twice, both in the constructor method as well as in the class name. So I have my class name enemy. My constructor method is now called enemy. Now it's not going to need all of this kind of if stuff because we don't want the enemy moving based on the keyboard. Otherwise we'll have two objects that are just doing exactly what the keyboard's doing, and that's not really going to be a lot of fun. So I'm going to get rid of a bunch of stuff there. So now it's ready to start figuring out how the enemy is going to update, and we can make the enemy display, as we are going to need that in a little bit. So we'll be adding the enemy in, and we'll have to create an enemy variable object and some other stuff in a moment. Now, because we're going to set it up so both objects on screen are going to be utilizing the same graphics for ease of use, we'll talk through how you would have a second group of sprite images that we could work with later on. But right now, what I'll do is I'll just color this one, my enemy, a little bit different. And what I can do to color it is I can use the tint command. And I'm going to tint it with red. So to do that, I just say tint, and then I specify an RGB color values so that my enemy is tinted with red. But I will want to tint my player sprite with white. So inside the display method, right at the beginning, just say tint. And if I do 255, 0, 0, 255, 0, that tints red. And I don't have to use red. I could use green. Well, the thing's already blue, so that'd be silly to tint it with blue. And I could use lighter red. I could use a darker red, whatever RGB color value I want. But this is good enough for what I need here. But now if I go into my sprite, I'll just give that a tint of white, which is 255. Or I could do 255, 255, 255. So 3 255s or just 255 gives me white. So if we run this project right now, we won't see any change or difference because we haven't added an instance of the enemy object to screen, so we don't see anything. But if you are curious, if you're breaking your project along the way, it's always a good practice to keep testing regularly and often so that you run your sketch to make sure that it is behaving. So if I run mine and take a look, we'll see that right now, okay, it shows up on screen. I can move with the keyboards and nothing bad is happening. I view that as a win. Now that we have the enemy class in there, it worked, it didn't break, nothing bad is going on. It's time to add the enemy into my project. So if I go up to the top here, I can just add an enemy. And I'll just call it E for short. Now I could come up with a more fancy name, or I could write out the word enemy, all kinds of good things, but I'm not going to right now. And then E is equal to new enemy. That now adds my enemy in. And the same way that I update and display my player, I can do e.update and e.display. Now when I do this, it's going to throw the enemy on screen, but by default the enemy is now, I didn't change in the enemy class to make it any different than the players, so they're both going to actually start out in the same spot on screen. So until I move the player sprite, we won't see anything. So I know that's a problem at the beginning. So in the enemy class, I'm going to change it so it's not starting at the same spot, but I'll just let it choose some random value because I'm a huge fan of random, and I'll just say 100 and then with minus 100, so it's going to be somewhere on screen. And then we'll do the same thing with Y. And you can choose other values, or if yours is different, you can choose different ones. Now, when I was doing prepping the code for this, I put width on both of these lines. And because it's wider than it is tall, I couldn't figure out why the enemy suddenly wasn't showing up on screen, because my random values were then showing up, way down too low. I was like, where'd he go? He's broken. So if you do things, if I say width here minus 100, we can see how that's kind of problematic, because my Y value could actually now show up off screen. So that would be bad. So you need to make sure when you're doing your Ys that you reference height. When you're doing X's, you reference widths, so that your players and characters show up on screen. And now I just collapsed down my key press and key release so we can see a little bit more on screen. So there's enemy with its random values. Enemy gets to update and display. I have a new enemy. I have my enemy class. If I run my project, cross my fingers, it showed up, and now there's the enemy tinted red. The player can run circles around him because the enemy does not know how to move yet. To get our enemy to start chasing after our sprite, we need to figure out then which is the bigger gap, a horizontal or a vertical gap between the two objects. So that requires the use of a conditional. So we do if, and in this case we're going to figure out what is the distance between my enemy's x minus the sprite's x. Now we use ABS. That returns an absolute value, because if the enemy is to the right of the player, so the enemy has a larger x value, I would get a positive amount. But if the enemy has a smaller x value, so on screen it's to the left of the player when I say x minus the x of the player or my sprite, then I'm going to end up with a negative value. But I want to know what is the actual empirical amount, the absolute amount, not whether it's a positive or negative difference between their x positions, so that we can do a comparison. So I'm comparing the absolute value of the difference between my x's versus the difference between my y values, y minus s dot y. And I'll put some extra spaces in there just for legibility purposes. So I'm comparing the absolute value and absolute value. So the absolute value of -5 and 5 is 5. Absolute value means when you look at a number, if there is a negative sign on it, you throw it away. That's all absolute value does. I throw it away. So if my x value is less than my y value, that means then the bigger gap is on the y value, so we'll want to move on the y's. if the bigger gap is on the x's, then we would move on the x's. So we'll see how to make that happen just a moment. Now what we also have to do is find out is if the y of my enemy is less than the y of, or the sprite's y. So we're comparing those two values. If that's the case, so if the y value is less than it, then what we can do is say speed x is equal to 0, meaning we're not moving on the x, and speed y will be equal to minus 2. So if the y, sorry, not minus 2, plus 2. If the y value of the enemy is less than the y value of the sprite, that means it needs to go down. So speed y has to be a positive number. And then we can just use a simple else. Speed x is equal to 0. Speed y is equal to minus 2. Because if we're not going to move it down, we want to move it up. So what this first if says is if my x's are less than my y's, we're going to close the big gap and move the y's in. Now, we could run and test this right now and keep positioning. So right now, it's only going to try and catch the player on the y value. We can see so it's trying. But when I get to the point that the x is too big, then we now need to work the x value in to the situation. So right now it's moving on y's. Now that it's chasing it on the y's, so we know that if this is the case, that we're adjusting the y's, because that was the bigger gap. But if the bigger gap isn't on the y's, but is on the x values, then what we can do is just simply do an else, because it really is. It's either going to be, we need to close the y gap, or we'll need to close the x gap. Oh, wrong button. Now, you could retype all of that, or you could copy paste and then just change y's to x's, which is what I would prefer to do. Otherwise, it's going to be nearly identical. So we can put comments in and say bigger gap on y-axis, bigger gap on x-axis. Now, if we test this, and it's really common when you're doing this, sometimes you will have the value you put minus and the value you put plus on, you have this flip-flop, so the enemy actually runs away from you instead of chasing you. So when I was working on the demo file for class tonight, I had my minuses reversed, so every time I got near the enemy, it ran away. I was like, whoops, got to flip those around. So it's really easy as you're doing the mental gymnastics of trying to get it to show up on screen. So now I can move and see how the enemy is trying. It's trying to close the gap. Now it's always chasing me and I don't have any safe harbor. And what we may want to do is to set it up so that we have some other options, such as perhaps when the enemy chases us, it won't pay attention until we're within a certain radius of the enemy. So only when it's a certain closeness to us does it begin the chase. Otherwise, this gets really difficult. Now that the enemy is chasing, it's time to reduce the awareness of the enemy so it's not aware of the player the entire time. So I want when I get within a certain distance of the enemy. So what we are looking for is when the player is less than, I'm going to choose a nice round number of like 200 pixels away, start chasing. So I put a comment in to kind of talk about where I want this to go, because eventually we want our enemy, which in a little while is going to be the evil unicorn, evil pink unicorn with the rainbow tail, is going to start chasing down the player. So to do this, we need to find out. So we need to find the distance between where is the player and where is the unicorn. So we're going to ask that question. We're going to say, what is the distance? And if that distance is less than, in this case, 200, an arbitrary value, but it kind of works for this size thing, then I want it to start chasing. So I can say if, and the cool part about processing is it has a distance function built in. So I just say dist, and now I'm going to specify my 2 points. So I can say x and y of the enemy, and then I can say my sprites x and my sprites y. So if the distance between those 2 points, the player or the enemy's x and y and the player's x and y, is less than 200, then I want it to start chasing. Well, I already have the code to start chasing, so I just need to dump that up inside of this, or move this curly brace down underneath all of that, and then it will start chasing me. So I'm just saying, what is the distance? And if that distance is less than 200, game on. So that curly brace, it's easier in this case just to put it down here. Oh, wrong button. And then if I just move all of this over so it nicely indents. So I took all of my previous movement code and I wrapped it inside these curly braces. So if my distance is less than that, then we can do it. And for safety's sake, I should just do else. And now, if we want it to stay parked at this point, then I can do speed x is equal to 0 and speed y is equal to 0. Now that the enemy is chasing us, we're going to add in a second enemy. And what we need to do is we need to load those images into their own image array so we can work with it. It just makes it easier that way. So to do this, I need to have another image array. And I'll call mine enemy images. And I also need to have a separate frames value to go with it. I don't really have to, I guess. I mean, because during the update, we can just hard code that in for the sprite, but It's redundant, but I will set it up as a separate value. Now my unicorn is comprised of 6 frames at the moment because it was a quick animation job. So enemy images, enemy frames is 6, and now an easy way I could retype all of this or copy paste what I had for my sprite images and then change sprite to enemy frames to enemy frames. Doesn't really matter. I'm just going to retype just because I can. Enemy images is equal to new pimage, and it will be enemy frames of how many are being put into there. So I will have 6 evil unicorn images in my enemy images array. And then I will start populating that using my for loop. As I said, it is identical to what we did with sprite images, but this time we're just going to populate it with a different file. So I am using my unicorn. I will use number format NF, then I+1 to designate my starting value of 1. The number scheme as the images exported were 4 numbers, 0001, 0002, etc. And then we just need to add in the .png to complete our construction of our file name. So that now creates the enemy images array that has my 6 enemy frame pieces of artwork that I'm going to use. Once I have now loaded these images, and remembering that we always load images only in our main setup, because when I start adding in 2, 3, 4, 5, 6, 7, 8, 1,000 different copies of my enemy object, I don't want to load in 1,000 copies of each frame of image. I just want to reference my core group, because otherwise it will be super ugly down the road. Loaded my enemy images. The time has come to specify that I want my enemy to display a little bit differently, and instead of sprite I will change that to enemy, and instead of frames I need to change that to enemy frames, so it goes through the correct number of frames. So now it's going to use the images out of enemy frames. Now current frame, okay, just making sure each one does have its own current frame, otherwise that could have been really awkward. That would have been awkward. And now let's, if I run it, we will see that now my unicorn is tinted red. I forget, and we can also see that he's going really fast. But I did forget to remove the tint statement that I had here, so I can just comment that out. Don't need that anymore. Now when I run it, I get to see my glorious pink unicorn with his rainbow tail, and he is now chasing after me. So things are good. The world is looking up. Now we're also noticing, if you look on screen, you'll notice that the unicorn located himself, that if I were to draw a box that would contain both of these objects, we'd see the circle, its box, this top left corner, and that also corresponds to the box that holds my spastic unicorn. So they are drawing from the top left corner of their graphic file of their PNG element. So if I look at that circle, they are drawing from this top left corner, or in the unicorn from this top left corner. So when it looks for where it's going to be, It's not going off the center of its body or its head. It's this top left corner. That is the X and Y for this image. And that's something that we're going to want to probably tweak or update to get a little better interaction occurring within our program. Because the unicorn and the player are drawing to the top left corner of the box, this is where they're trying to go instead of to their center points. So what we want to do is we want to modify so the player and the unicorn are now being shifted in their drawing to line up with their middles. Now, to accomplish that, what we see that's happening is, in this case, like the unicorn, it's drawing at its X and Y position, which is going to be this corner, this top left corner in the box. So what we can do is we can now shift so that the artwork is not drawing there, but is drawing around its midpoint. And we can adjust that based on artwork. If artwork doesn't fill a box easily, like the face, my Cyclops, if I say a box, it's mostly full, but when I look at the unicorn, I may want to be registering off of a little lower spot, not necessarily the dead middle of this rectangle, but the dead middle would certainly be an improvement over what is happening right now. So this is where we can now shift how we are drawing that or working with that value. Now to do that, if we know the size of our artwork, which when we made the sprite, if we entered in a height and width, then I would put that in on the sprite information, or in this case, my enemy. My unicorn is 140 wide and it is 95 tall. My face, as I look at the face, is going to be 32 by 32, which corresponds to what I had previously inside my sprite. So my Cyclops is 32. The unicorn is a much larger, more stout 140 by 95. So once I enter in the correct values for that object, now we can draw it, instead of drawing at X, I can draw it at X minus half of its width. And I can draw it at Y minus half of its height. That now shifts over that point. So now when it draws it, it's going to shift the artwork. So if I run my program again, we will see how it's lining up, where it's lining the corner of the eyeball is lining up right about here. I'm going to switch the order of rendering so that the Cyclops gets to be on top, just so we can see it easier. So we can see that lines up a little bit better. But it's lining up based on the Cyclops in that top left corner, so we really should treat the Cyclops in the same way that we did the unicorn. So we shifted the unicorn over, so I can do the same thing to my Cyclops. So half of its width and half of its height, we move it over so it's drawing around its middle. When I run my sketch again, you can see it's drawing around the middle. Now that gives me a much better sense of interaction. So now get close enough, it hops over to where I am. Get close enough, it hops over to where I am. So it's trying to find me. So that's a nicety. That cleans up a little bit of what we're doing within the game. Now there's some other things we could do where we could work on flipping the artwork so that the artwork flips. So if I'm going left and going right, or rotate it. So there's some other complexities that we can work into the process. But for right now, this gives us a good starting point. This gives us a basis of getting our project working and interacting so that we have our enemy chasing after us. All right, I broke something here. Oh. Right. Forgot to bring back update and display for it. Like, it's not showing up. Why is it broken? All right, so now I forgot to update. So now through that little section that I really should cut out in the video, we can see he's parked. But if I get close enough, then he walks, move away, done. Okay, that's just hysterical to watch. Oh, and the moonwalking unicorn? Yeah. Okay. He doesn't need no stinking flip. He gets to just walk backwards because he's too cool.